Hello, I'm David Spurway and I'd like to introduce you to IBM Power Systems. I'm the product manager for Power Systems in the UK and Ireland, and so I'll take you through some of these, generally quite fast because that's how I generally do it. Fast, after all, is also what I see as Power Systems being there for. IBM Power Systems are there to make things go faster. That's, as far as I'm concerned, the kind of point that we have for these boxes. They're there to make things go really fast, and that means you can either do things which allow you to be able to get your business process to be faster than your competition, allow you to win your race, and or you can also do more with less. Particularly our larger servers are particularly good with this, where you can do lots of different things at the same time on the same server and be able to lower your costs at the same time as being able to do more. So, would you like to be able to know how these work, how these actually work? Basically, they are the fastest around. These are very, very fast processors and be able to move for your business processes, move through really quickly. So, bottom line, after all, as far as I'm concerned, is what would fast mean to you? What business process have you got that you'd actually like to be able to see go that much faster, as IBM Power Systems may well be able to help there? Now, do you believe what I'm selling you? Do you believe me that when I say actually that these particular boxes do go that fast, and can you actually understand the benefits of that process? Potentially, you might need a quick refresher in computer science. That's one way potentially we could do this. After all, to be able to get your data today, you need to be able to get the information up into your processor core. So to be able to do that, you have to be able to take the information and pull it up from your disk and be able to pull it into the disk from the adapter, and then be able to take it from the adapter into the memory, and from the memory into the cache, and from the cache up into the processors themselves, and be able to get it into the processor cores. And then you can get your answer. But it is possible that all of that, if you're not a computer scientist, is actually gobbledygook. And therefore, let me take you through it in a slightly different way. Potentially you're not a computer scientist. Potentially you might just be able to believe this from a different point of view, because you really don't need to be a computer scientist to be able to get the benefits from IBM Power Systems. As I say, the bottom line is, what would actually mean to you from a business point of view is IBM is able to make your business processes go that much faster. So let me take you through an analogy instead, which involves taking my children to school. Because the sort of method here that I'm working with is that if I'm going to be able to get my data up into my servers and be able to get answers from that, it's a little bit similar, taking my children out of the house, getting them to school and getting them to learn things. Very similar as far as I'm concerned in analogy. So let me take my children to school and take you with me. We have, inside of our systems, really, really fast processors, which is a little bit like Neo learning Kung Fu in the Matrix. He learns it really, really fast, and we can do this excellent and very, very fast. More information about that in a second. Also, we have the benefit of Hermione Granger's time turner. That's what that is Hermione Granger's time turner. And in Harry Potter, Hermione Granger, who desires to see more lessons than one at the same time. She goes to multiple lessons as she goes along, and SMT inside of our servers allows us to do the same thing. We can run 8 different threads through the same processor cores at the same time, allowing us to do multiple lessons, learn multiple things at the same time. So to give you some detail, there is all sorts of numbers here. All of this is published benchmark material. This is stuff from our competition, from Haswell. This is their best result. This is our information, our servers. This is the best result there. And on the end, how much faster we are per core. So to zoom in and make that a bit easier, for an example, on one benchmark using SAP 2D, we are over twice the performance per core than our competition. And that's because of the performance of the servers themselves, the processors themselves, and also SMT at the same time. So we can get excellent results for your business processes by going really fast. Then, of course, do you actually have enough to be able to do? Personally, most of us in our business daily lives find that we have plenty to do, but can you keep your servers busy and occupied and doing useful things? One of the challenges, after all, is that if you have, as I take my children up to school, if the car park is not big enough to be able to get my information or my cars into the car park and take my children to school, if the car park's not big enough, problems can occur, like this interesting car parking trick at this point. The cache, for me, inside the processors, is a lot like the school car park. If the cache is big enough, you can get the information in very easily and be able to continue working. If the car park's not big enough, you end up queuing down the street and it's really annoying and you take ages. So our cache is really large. Here we have the kind of numbers for cache where it comes to competition. Here's the number we have for Power Systems, and we've got something like 20-ish, 19.27, compared to 2.81 per core on our competition. So much larger caches, meaning we can keep busy and keep working. Keeping busy and keeping working, after all, is ideal to avoid bottlenecks. This, for example, is what happens as you may drive around the country, as I've done in the UK and indeed had some of this morning, where you lose a couple of lanes on the motorways, things slow down. If you lose 2 lanes in the motorway, you don't just drop to a third of the speed, you drop to complete standstill and you end up chugging along. And that's exactly how it works inside of computer systems as well. So because we have much larger elements, much larger caches, much higher performance, we can keep everything moving along very nicely and avoid these bottlenecks and allow the whole system to perform optimally. It also means we can actually use the processors, very high levels of utilization, because we can keep them all busy. Memory bandwidth is another area which potentially can be a bottleneck. This bar here for Power 7 looks small in comparison to what we've got with Power 8 these days, but this was actually what was the excellent memory bandwidth and the reason we used Power Systems to create the Watson solution in the first place. We actually found that memory bandwidth was a challenge in that large and big data kind of workload, and so we used Power instead of Intel to be able to create Watson. We took that good answer and made it much, much better for the new big data workloads we now see and we work with Power Systems. So very large memory bandwidth. And much larger, there's the memory bandwidth down here for Power Systems. These are the numbers for our competition. Much larger memory bandwidths are possible using our particular systems inside of IBM Power Systems compared to the competition. Similarly, on the I/O side of things, we can do good things there. We can also begin to add other things like FPGAs or indeed NVIDIA's GPUs. We can attach those to our boxes as well and create an I/O in a new way that hasn't been possible before, using things like CAPI and also in the future NVLink. Also, one of the other things we can do with our large boxes is we can take our brains and we can move them around, which when you've been to school for a little while might be really, really useful if you could take your brains and move them around. With enterprise system pools, we can actually have brains inside of our boxes and move them around the cores and the memory inside of our servers. We can move them between physical servers to allow you to rebalance for different kinds of workloads, also maybe take systems down for plant maintenance, lots of other things you can do with these different systems. So at the end of the day, Power Systems are designed for big data. Very large amounts of cache, very large amounts of memory bandwidth, very excellent systems to be able to move the large quantities of data around we have in our workloads these days. They are also open innovation by design. The Open Power Foundation is an excellent example of that, where we're opening up the intellectual capital of how we do things and be able to open that up and work with these very interesting and very smart people in the room, other systems available about that, to be able to see innovation coming back and forth from these different parties. And we can also do superior cloud economics. So at the end of the day, that's what Power Systems are here for. And so if you have any questions about that, feel free to come back to me and ask me as needed, and we'll see what we can do. Thank you very much indeed for your time.